Hello, and welcome to the mini lecture covering cell potentials from our Chemistry 1412 course with Dr. Elizabeth Bell. Today we will focus on cell potentials and how to calculate them. Different redox reactions will have different cell potentials. If you choose your two reactants correctly, you can maximize the cell potential. Let's talk about how to do that. The cell potential, or cell standard EMF, is the difference of the standard reduction potentials of the two electrodes. Each reaction has a standard reduction potential, which one can look up in a table. You compare the two potentials, and then the one with the larger potential will be reduced, and the one with the smaller reduction potential will be oxidized. All reactions listed in the table are shown as reductions. Once you discover which will be oxidized, you will know that this is the one whose reaction must be flipped so that the products are reactants and the reactants are products. If you flip the reaction, you must also flip the sign on the reduction potential, making it into an oxidation potential. Then, add the two potentials together. Another way to look at it is to subtract the oxidized potential from the anode from the reduced potential at the cathode. If you are leaving them as reduction potentials, always subtract the lower one from the higher one to get the cell potential. To reiterate, the more positive the reduction potential, the more likely it is to be reduced. If it is reduced, it is also the oxidizing agent. Here's a section of the table of standard reduction potentials. Notice that they go in order from largest to smallest. If you find your two electrode reactions on the table, then the one on the top will be the cathode, where reduction occurs, and the one that is on the bottom will be the anode, where oxidation occurs. Rarely are galvanic cell reactions conducted at standard conditions. This is where the Nernst equation comes in handy. Given any concentration of reagents, one can calculate the cell potential of a galvanic cell. The non-standard cell potential is equal to the standard potential minus a constant divided by the moles of electrons being transferred times the natural log of the reaction quotient. Remember that Q is simply the concentration of the products raised to their coefficients in the balanced equation, divided by the reactants raised to the coefficients in the balanced equation. Spontaneous redox reactions are used to build galvanic cells. This chemical reaction produces a current spontaneously. Non-spontaneous reactions can be forced to occur if you supply a current. This is called electrolysis. Any metal plating which is done, whether for jewelry, cutlery, etc., is done via electrolysis. Michael Faraday was the first to calculate mass quantities produced from electrolysis experiments. The constant used in these calculations was named for him. Thank you for watching the mini lecture from our Chemistry 1412 class with Dr. Elizabeth Bell. Please go to Sapling at this time and do the associated assignments. Do not hesitate to contact me with questions. I am happy to help.